I gave you so many particles. Let's say I gave you 1.8 times 10 to the 24th molecules of water. Okay, well, a molecule is a particle. So I would be over in this particle box here. And if the question said, well, how much does that weigh in the lab? Let's say I wanted you to weigh out that one. Well, that's really simple again. I want to go from particles to mass, but the problem is it takes 2 jumps. So I would need 2 brackets to do the math, okay? And then when you do that, you just got to follow the jumps. Remember the rule. After you count your brackets and figure out where you're going to, the rule is the one you want goes on top. I want to go from particles to mole, but I have to use this bracket right here. The one I want goes on top. I want mole to be answered, so I need to flip this bracket over. So I need to put 1 mole on top, and then 6.02 times 10 to the 23rd on the bottom, but I want to use the word molecule, and that allows me to cancel out the word molecules. Okay? Then the next jump, I want to go from moles to mass. Then I need to use the molar mass again. Okay? That's up here in this box. And then I go, if I'm dealing with water again, I can keep using this number. Okay? And so I want to go from moles to mass. Mass should be on top, so the 18 grams go on top. And I put 1 mole on the bottom. But remember, if you just watch your name like we did in all our other conversions, what name I don't want needs to cancel out. The name I should get should be on the end, on the top. So all I need to do is math. And I know 18 divided by 6 is 3. So this is going to be an answer of 3 here. And then 3 times 18 is 24. So it's going to be 54 grams. Okay? So that's what's going on there. Okay? So that's how you do it. What you do is 4 simple rules. Is number 1, you write down your given number. Number 2, you then go to your chart, figure out where you're starting, where you're going to, count the number of jumps. Put a bracket for each jump. Step number 3 is go back to the chart. As you make a jump, use that particular bracket. Flip it over if you need to. If you're going to moles, mole goes on top. If you're going to particles, particle goes on top. Fill the brackets appropriately so all the names cancel out. And then your math will show up. Follow the math. Everything on top is multiply. Everything on bottom is divide. Do the math. Make sure the correct units come out at the end. And that is the correct answer. And what you've done is you've changed this number into this number, but it's the same quantity. It's just been converted to a unit you need. So if I wanted to get that many molecules of water, I would have to weigh out that many grams of water in the lab. Okay, we want to do one last problem with the conversion chart again. Remember, I had a conversion chart. These are our brackets. Remember, these quantities are equal, so all it's doing is just changing one name into another name. And in chemistry, sometimes we need milliliters or liters in a certain chapter or equation. Sometimes we need molecules, sometimes we need grams. And so this chart just changes it to whatever form you need. So let's just give another example. Let's say that we're collecting a gas in a tube. Let's say we're collecting carbon dioxide. So we're going to deal with carbon dioxide, and let's say that we collected maybe 11.2 liters of that gas in this gigantic container. We want to figure out, well, how much would that container weigh because of the extra gas inside? So if I want to find mass, so I want to find grams, that's my goal. Then I look to my chart. I've been given liters, which is a volume number. So I go over here. Here is volume. Down here is mass. So it's going to be another 2-jump problem. So I would need 2 brackets. Okay? The first jump, since I'm starting in volume, would go from volume down to mole. And the rule I gave you was the one you want goes on top. So I want mole on top because that's the box I want to end up at as I work my way towards mass. So we're going to flip this thing over. We're going to put mole on top. Put 22.4 liters on the bottom. Okay? And so what that does is, remember, it cancels out the units we don't want. So you really can't get these wrong if you watch the names like we've taught you. Okay? So now, that's because it's one jump, but I got to finish my next jump. I need to go from moles to mass, To go from moles to mass, I would want mass on top, so molar mass goes on the top. And as you notice, we don't have a number like these. That's because every formula has a different weight. So to figure out the formula weight, or molar mass, I've got to go back and figure out the weight of the formula. Carbon, since there's only one of them, weighs 12.0. Oxygen has two of them, and they weigh 16.0, rounded off. And so I would multiply them through, I would get 12, and I would get 32. And if I added those two together, each one contributing, I would end up with 44 grams for the formula weight. And so I put that on top, molar mass, for carbon dioxide, 'cause that's the compound we're dealing with. The other one was 1 mole. So my moles cancel out, my liters cancel out. I'm going to get a gram answer. That was the goal. And so I just do the math. 11.2 divided by 22.4 is a half. Then a half of 44 is 22, and it would be grams. And so I've changed this liter number now into a gram number. So that container in lab would have an extra weight, because of the carbon dioxide, of 22.0 grams more. Okay? So that's how you convert. You just simply find the jumps you need, fill in the brackets by the direction you move through the chart. So, and then as you fill it out, the units you don't want should cancel, and then the one you want should be at the end. Then you simply do the math by multiplying the tops and dividing the bottoms.